In LUSAS version 23, there are various user experience improvements. In this video, I'm going to look at improvements to load visualization, at how we can now extract tabular results direct to Excel spreadsheet, and also how we've improved the definition of reinforcement for reinforced concrete slab design. In this model, you'll straight away notice the first improvement to load visualization, in that the loading arrows now have both a magnitude and a unit to tell you the exact size of each load that is applied to the model. We've also improved the options for visualizing loads. We've always had by definition and by effect on model. We now have the by effect on mesh, and that's also allowed us to do some improvements to the effect on model as well. So what we're seeing on screen at the moment is the load visualization by definition. This is the load that has been defined by the user. In this case, this is a vehicle load with multiple individual point loads. If we switch to looking at the effect on the model, we can see straight away that some of these loads are now grayed out. That's because they are missing the structural model, and therefore they are loads that are being excluded. They're not actually being applied to the model. The loads that are being applied to the model, we can now see, or we can still see, are shown in the cyan blue color. If I just select an element under this 25 kilonewton load and zoom in, the next thing I want to show is the load visualization by effect on mesh. So this 25 kilonewton load is in the middle of an element, but in order to actually do the finite element calculations, we need to turn that into nodal loads. And what the load visualization by effect on mesh does is it shows you the actual nodal loads that will be used by LUSAS in order to do the finite element calculations. So we can see that that 25 kilonewton load has been split up into individual loads on the 4 nodes, and they add up to 25 kilonewtons. And if we zoom back out, we can see that a similar thing has happened for the other loads as well. If we switch back to load visualization by definition, I'm going to change to another load case for lane load. So this is a uniformly distributed load over an area, a patch load. I've used an option for an 8-node patch. An 8-node patch, instead of having 4 corners, it also has 4 points defined halfway down each edge. And if we look on plan view, we can see that what I've done is I've used that to create a curve within the area load. So although it's relatively subtle, hopefully you can see that it is curved following the curve of the overall structure. Similarly to the point loads, we can now see we've got a load magnitude and also a unit set. So this is a kilonewton per meter squared. This is an area load. If we switch to the load visualization by effect on model, we can see that that load has been split up into individual cells. Any cells that have missed the structure are shown in grey, much as the point loads which missed the structure were shown in grey. We can't see the individual cells on the structure here very clearly. If I turn off the mesh, we can see them a bit more clearly, and we can see the individual cells. Now, each of these individual cells will have a load applied in the middle that's calculated from that 10 kilonewton per meter squared area load. That load is then distributed out to the adjacent nodes in the same way as the point loads were. So if we change to look at the visualization by effect on mesh, we can see the individual nodal loads. Now what you will see is that we've got some variation within the nodal loads here. Although we defined it as being 10 kilonewtons per meter squared, the process of splitting it up into individual cells and then finding nodes to apply those loads to has meant that the actual nodal loads are not completely uniform. Now we can improve that by going into our attributes and double-clicking on patch divisions and maybe increasing the number of cells, number of patches. Now this is something that LUSAS has always done, but what we're doing with this new load visualization is exposing it to the users a lot more clearly so that you can understand exactly what calculations LUSAS is doing. The next thing I want to show you is the results extraction, but as we've changed the patch divisions, we can see we've got modification mode results are out of date for this load case. If we switch back to the load case with the vehicle load, because that wasn't affected, we can still get previous results for this load case. In order to get the tabular results, we're going to go to Utilities, Print Results Wizard, as we always have. I'm going to get nodal displacement results as a table. So I'm going to call this displacement for vehicle in position 2. Now we've always had this display now option. The new option that we have is save to file. So if you then double click on the 3 dots, you can define a location and a name for a Excel spreadsheet, displacement vehicle position 2. And then we can choose if we want to untick display now. And then when we click OK, the results will be saved straight to a spreadsheet in the location defined rather than being shown on screen. This is very useful if you want to process the results outside of LUSAS. It removes a step. It used to be you had to display the results on screen and then right-click and save to Excel separately. Also, when you're running with a very large model, displaying the results on screen can be quite slow, and it's actually much faster to export them to Excel. And it's also repeatable. We can right-click in the Utilities tab and click Save to Excel in order to export it again, should our results have changed. The third thing I want to show you is reinforcement zones for surfaces. If we go to Attributes, Design, and Surface Reinforcement, if we are carrying out a reinforced concrete slab capacity check, instead of having to do one reinforcement for the whole of a surface, we can now vary it within a surface or even vary it across multiple surfaces. What I'm going to do is define reinforcement that I'm going to use for the whole of my deck, for a whole structure. So I'm going to insert 2 more columns. So we've now got 3 different reinforcement zones running in the global X direction. I'm going to make the middle one stretch to fit and make the 2 end ones 12 meters long. That means that whatever reinforcement I put in this box and this box will be 12 meters at the start and end, measured in the X direction, and any other length in between will be filled in with whatever reinforcement I put in the middle one. So I'm going to create a new cross-sectional reinforcement. This is the new dialog for cross-sectional reinforcement. And in the top, in the X direction, I'm going to put 32mm bars. And this is going to be reinforcement over supports. I'll use the same one at the other end. And in the middle, I'll have reinforcement in the span. And that's just going to be 20mm bars everywhere. I'm going to call this rebar for deck. Then I'm going to select all the surfaces that define my deck and drag and drop rebar for deck. Instead of considering each selected item individually, i.e. assign that reinforcement with the 12 meters either end to each individual surface, I'm going to consider the whole selection as a single assignment. So any surfaces in the first 12 meters will get the reinforcement over support. Any surfaces in the last 12 meters will get the reinforcement over the supports. The rest will get the reinforcement in the span. And that 12 meters is going to be defined following a reference path that I previously defined in my model, which follows the curve around the center line of the deck. And those are the user experience improvements in LUSAS version 23.